In this lesson, we will learn the properties of ionic compounds, and we will also compare the properties of ionic compound with the covalent compound. Before we start learning about the properties of ionic compounds or covalent compound, we need to know how these compounds are formed. In case of ionic compounds, a metal and non-metal react, while in case of the covalent compound, both are non-metals. So let's say this is an ionic compounds, and we have the metal as sodium. So sodium is metal, and chlorine is non-metal. So ionic compound is always formed between a metal and non-metal. And the metal always becomes cation by losing electrons. So initially it has 11 electrons and 11 protons and 11 electrons, but then it loses one electrons and it becomes a cation. So now this is sodium cation. And on the other hand, chlorine atom it has 7 electrons in the outermost shell. It gains one electrons and now it is chloride ion. So plus and minus. You notice that in ionic compounds, the electron completely leaves its parent atom in when it forms cation. All right, so complete transfer of electrons happen. That's why it becomes fully positive and fully negative, not partial positive and negative. Now, once they are positive and negative, just like any positive attracts negative, they come close and attract each other. Now, many students are confused here that, oh, once they form NaCl, one Na1Cl, they are free to move. No, they are not. Because although they cancel each other's charge, but still they act like small magnets, and they attract any negative around them, and then those negative attract any positive around them. So sodium chloride or any other ionic compound, they do not exist as independent, freely moving units. All right, so they are like this. For example, there is a positive cation here. It is bonded to anion from all the direction, up, down, back, front, and that anion is further bonded to positive, negative, for front, back. So ionic compounds never ever exist as single units. They exist as crystals or lattice. So the lattice crystal is only formed in the ionic compounds. For example, if you take a pinch of salt and you pick the tiny, really tiny crystal of salt, that is crystal. It has millions of cations and anions there together. So you can't see one cation, one anion bonded together, moving freely. All right. So this is first thing we need to understand, that in ionic compound, a metal which becomes cation and a non-metal which becomes anion, they react together and they're not free. They keep attracting other positive and negative until they become crystals, lattice crystals. All right. So on the other hand, if you look at the molecular compound, which has two names, the covalent compound or molecular compound. So there is no complete transfer of electrons. So let's say this is hydrogen atom. It has one electrons, one electron in the shell. There is second hydrogen atom. So the sharing of electron is happening. No complete transfer of electron is happening. No one is donating or accepting the electrons. They're sharing the electrons. All right. So the oxygen, it has 6 electrons. It needs 2 more. All right. So one comes from each hydrogen by sharing 1 electron. And hydrogens, they need only 2 electrons in their first shell. So they just share with 1 electron. And what happens eventually? Hydrogen has the 2 electrons in its shell. All right. And oxygen has 8 electrons in its shell. So this is sharing of electron. Now, once you have this molecule formed, which is like this H2O, all right, this is not attracting all the H2Os around it. For example, your air has a lot of moisture in it. All right, H2O is there, but it's not attracting all the H2O molecules and They're not bonded just like ionic compounds. Yes, there is a weak force. There's a weak force because of partial positive and negative charge, all right, which attracts water molecule. And when that happens, water molecule is in liquid state. But that is weak force, all right. Now, that's why water molecule, or in case of hydrogen gas H2 molecule, all right, they move freely because they are not forming crystal or lattice structure like the ionic compounds. Once the molecule is formed, in case of H2, let's say this molecule is formed, it's not attracting other H2 to it because there's no positive negative, there's no attraction. Similarly, in case of water, once the water molecule is formed, it is only weakly attracting other water molecules. That's why it's liquid. If there was no attraction at all, it was gas, but it has weak attraction. That's why it's liquid. So there is no lattice or crystal structures in covalent compounds. All right. So once we understand this, let's go to the some reasoning questions. Now, first question is that why ionic compounds are solid, hard, and dense, while covalent compounds are mostly liquid and solid. In the previous slide, I briefly described that. If you form, let's say you have H, an atom, another hydrogen atom, they react and share their electrons and become H2. Now, this H2 is not attracting other H2 molecules. That's why it's freely moving. When a unit is freely moving, it is called a molecule. So only covalent compounds are called, their units are called molecules. You cannot call ionic compounds unit as molecules. So molecules is only for molecular compounds or which are ionic compounds. On the other hand, if you have sodium, like I gave you example, it becomes cation and chloride. Chlorine becomes chloride and they become NaCl, and they are now eventually become this crystal structure. They don't exist as molecule, but if you take only one unit of that, so that is called formula unit. So they don't exist independently. All right. So the smallest unit of a covalent compound is called a molecule. Smallest unit of a crystal, lattice crystal of ionic compound is called formula unit. Now, why the ionic compounds are solid? Because they are crystalline structure and every ion is bonded to other ion, cation or anion with strong ionic forces, electrostatic forces. In molecules, let's say H2 molecules, one molecule is not attracting at all. One H2 molecule is not attracting another H2 molecule at all. So that's why it exists freely as a gas. But let's say there are some attraction between water molecules. They have some attraction for another water molecule, so they exist as liquid. So they cannot exist as solid at normal room temperature because there is no strong forces like ionic compounds. So how do you answer that? Ionic compounds are solid or dense or hard because of strong electrostatic forces. All right, this is the reason. And those strong electrostatic forces eventually lead to become a crystal and lattice structure, which is not the case in covalent compounds. Now, why ionic compounds only conduct electricity when they are molten state or when they are in aqueous solution, but they do not conduct electricity in the solid state. So what happens when the electricity is conducted? So the ions, this is cation, the positive is cation, and this is anion. They need to be moving around to pick those electrons. Let's say electrons are sitting there, and if the ions are not moving, let's say cation is not moving, it cannot go up to that electrode and pick electrons. So in ionic compounds, we want ions to be moving so they can go around, pick electron, drop electrons. So ions are just like taxis here. They go pick the passenger, which are electron, they take them to the other side. So if the ions are not moving, they cannot conduct electricity. All right. So why ionic compound conduct electricity when in molten state? In liquid state, which is molten, like melted, or solution in water. In liquid state, ions are moving. All right. Ions are moving so they can conduct electricity. In solid state, in solid state, ions are at a fixed position and cannot move. All right. Because they cannot move, they cannot receive or drop off electrons. All right. So in the molten state or solution state, because ions are moving, they can carry electrons and conduct electricity. In the solid state, ions are fixed. They're not moving because they're in solid state, in crystalline lattice. So because they are at a fixed position, they're not moving, they cannot carry electron, they cannot conduct electricity. Now, next one is why ionic compounds are brittle. So brittleness is a property of ionic compounds only. When you hammer it, when you um, apply pressure on the ionic compounds, they're not malleable like metals. They they um, they break down with a snap. All right. So this is called, for example, if you have some pots in your kitchen, and sometimes you break the glass. All right, you see that as soon as it drops, it hits the ground, it break down. It doesn't change the shape. That's called brittleness. So what happens that, let's say this is the original ionic compounds, and let's say the red one is positive and the blue ones are negative. All right, so initially they are like this. So when you hit hammer or apply the stress or pressure, the top layers move. Now the same charges, let's say positive, come in front of positive and they repel each other. When this repulsion happens, they eventually break down, and so you can say that when the pressure is applied, the top layer of the ionic compound slide over, and the same charges, they face each other, with which makes them repel, and that's why they are brittle. Now, why some ionic compounds dissolve in water and other do not? First of all, we need to know that water is a polar molecule. Now, what does that mean? It means that water has positive and negative charge. All right. Why oxygen is negative? Because it is more electronegative. It pulls electrons towards it and becomes partially negative. Now, it can dissolve in it only the compounds which are either polar covalent, not just covalent, polar covalent, or ionic. Why is so? Because then it can make bonds with them, and will be attraction between water molecules and those polar covalent or ionic compounds. But let's say if you have oil, a spoon of oil in water, they never mix up. Why? Because oil is non-polar, water is polar. They don't recognize each other. They don't attract each other. All right. So first of all, water is a polar molecule. It only dissolves compounds which are either polar covalent or ionic compounds. All right. Let's see now. Let's say you have a pinch of salt. All right, and you try to dissolve in water. So you added this in water. So you have this pinch of salt, which is negative, positive, negative, positive, negative, positive. So this is crystalline structure. Now let's say you added water in water. So water has negative charge and positive charge. Yeah. So what water does? What water is attracted towards salt. Why? Because salt has positive, negative as well. So let's say this negative of water attracts this positive. All right. And this positive is attracting this negative. Now, this water molecule is trying to pull out the cation and anion from the crystal. And once they are separated, like chlorine is here, chloride is here, and sodium is there, water molecules surround them and have party. Like this process is called hydration. Now, chloride is hydrated and sodium is hydrated. All right. So the process is this: you add salt, the positive and negative, they are bonded electrostatically, positive and negative, cation, anion, they are bonded. All right, this is dotted line mean this is weak hydrogen bond forces with the metal. And basically, water molecule is trying to pull out the cation anion. Once the cation and anions are separated, they are surrounded by water molecules. All right, like this. Water molecules are like happy now. They won and they're having party now. This process called hydration process. So here the sodium is hydrated, and here the chloride is hydrated. So basically, the process is this: water molecule is polar. When you add salt in water molecule, in the water, the salt will dissociate into cation and anion. And this dissociation is happening. Why? Because hydrogen positive and oxygen negative is making bond with these ions and trying to separate them. But not all the ionic compounds dissolve in water. All right, let's say sodium and chloride, when water molecules come and try to pull them apart, they separate. All right. Why? Because their bond, the positive and negative electrostatic forces, is weaker than water and chloride or water and sodium bond. All right. So the only ionic compounds where the cation and anion electrostatic forces are weaker than the water and ion bond, they will dissolve. But let's say you have another compounds, copper carbonate, their bond is so strong that water molecules, they try to pull them apart, but they don't break up, they don't dissociate, which means that it will not dissolve. So not all the ionic compounds dissolve. The the ionic compounds where the cation and anion electrostatic forces are very strong, they will not dissociate, they will not dissolve in water. I give sometimes example to you guys, students, that it is just like that. If there are two kids, so child one is holding second child's hand, and parents come, all right, parents come and try to separate them, they can do that. Why? Because parents' force is stronger than kids' own force of attraction. So that can happen. So this is the example of like NaCl. So NaCl can be separated. Why? Because water can pull them apart easily. But let's say two parents are holding, parent one and parent two, they are holding each other's hand, and kid one and kid two come and try to separate them, they may not be able to do that unless parents want. Why? Because parents holding or force of attraction is very strong. All right. So same applies to some ionic compounds. When their cation and anionic forces are very strong, water cannot separate them. All right. And but in some compound it's possible. So I hope you understand these properties of ionic compounds. This is a very important topic for SAC for exam. So please go over this again, maybe again and again, until you understand fully. All right. Thank you. I hope you enjoyed the lesson.